Alright guys, welcome back to Underground Science, and in today's video we're going to be talking about alkanes, and mostly the basics, okay? So let's jump right into it. So alkanes are basically hydrocarbons, and what I mean by hydrocarbons is, if we look at this molecule right here, the only thing present in this molecule are hydrogens and carbons, hence hydrocarbons, right? So these orange dots that I'm drawing represent the carbons in a line diagram. And then let me choose another color. Let's do blue. And the hydrogens are also invisible here. Okay, so the blue are hydrogens. Okay, I'm not going to write it all out, but you understand that each carbon has to follow the octet rule, so it can only bond to it can only have 4 total bonds. And so if we check, let's make that a little bit neater. If we check, each carbon will have 4 total bonds. So this carbon right here, right, will have 1, 2, 3, and then 4. This carbon here will have 1, 2, 3, 4, and so on. And so that's why it's called a hydrocarbon, is because, or alkanes are called hydrocarbons because that's all there is in here. It's just carbons, 1, 2, 3, 4, 5, and then hydrogens, which are the blue bonds to hydrogens. That's it. Okay, so now that we know that, let's go over the formula for alkanes. That will make it way easier for us to quickly come up with the formula. Okay, so the formula for alkanes is CnH2n plus 2. Now this formula will be useful when we start actually identifying alkanes, naming alkanes and all that, and recognizing alkanes. But let's start by putting or writing down all the alkanes, the basic alkanes that we should be familiar with, and then talk about them. So I took the time to type it out, and so we're just going to practice on here, okay? So the first one that we should start talking about is methane. Now if we look at the suffix on all of these is ane, and so let's make a note of that. So in all of these, the suffix is ane. Now the suffix for all of these is ane. That's important to know because in the future videos, when we're diving deeper into like naming and molecules reactions for organic chem, there's not just going to be alkanes, there's going to be alkenes, alkynes, and you know, other functional groups. So let's make a note of it that all the suffix for all of these are ane. And the main thing though we have to focus on is not the suffix, it's the prefix. So if you see methane, you have to focus on the prefix meth. The prefix meth means 1 carbon. That means that this molecule is only 1 carbon long, okay? And we'll go into the actual formulas later. So let's just get this down first. Eth, right? Eth means, let's keep the colors consistent. So eth, the prefix eth means 2 carbons. Okay, if we keep on going down the chain, right? Prop, the prefix prop means 3 carbons. And it's important to have these memorized, the prefix memorized, because that'll make it easier when we're, you know, naming molecules. Bute, the prefix bute, oops, that was too much. The prefix bute is 4 carbons. The prefix pent is 5 carbons. Right, and so on. So let me go write it out and then I'll come back to it. Alright, so far this seems pretty straightforward, right? You just know the prefixes and then you know how many carbons it has, like we went over. Okay, so just to review, methane, 1 carbon, eth, 2 carbons, or ethane, 2 carbons, propane, 3 carbons, butane's 4 carbons, pentane's 5 carbons, hexane is 6, heptane is 7, octane is 8, nonane and decane are 9 and 10 respectively, right? Now, what do we do with this information, right? In the future, this will be helpful when we have to name alkanes and identify alkanes, right? But in this video, we're just focusing on the basics that we just went over right now, and the next thing we have to focus on is the formula. So in the beginning, if you remember, we said the formula for alkanes was CnH2n plus 2, right? Let's write that more in level. All right, so what does this even mean? But we said in the beginning that n, right, was the number of carbons. Okay, So let's just dive into example right away. If someone says, give me the formula of pentane. Okay, so let's write down pentane, and we're going to give the formula by following the formula rule. So pentane, because we already went over the prefixes, we know pent is 5 carbons, right? So that's the N value. So it'd be C5H, and then 2N plus 2. So what's 2 times 5 plus 2? That's 10 plus 2, right? Which is 12. So that'd be C5H12. That's it, right? That's the formula for pentane. Someone says, all right, give me the formula for octane, right? You guys probably got it by now. But octane, because of the prefixes, oct, right? The prefix oct means 8. So that we know that N is equal to 8 carbons. So following the formula, we would say C8H and then 2N plus 2. So 2 times 8 plus 2, right? This is pretty straightforward. That's 16 plus 2. So what would that be? 18. So the formula for octane would be C8H18. So just like that, you can come up with the formula for any alkane, right? As long as you know the prefix and how many carbons that prefix has. But you don't even need to have this. If you don't want, you don't even need to have this formula memorized. You should, because it's way quicker if you have this formula memorized. But if you just know the prefix, right, that we talked about of each alkane, then you should come up with the actual formula without knowing this formula. And so if we were trying to have an example of that, if someone said, okay, give me the formula, or yeah, give me the formula of propane, right? So propane, we know, is 3 carbons, right? Because prop is 3. So remember, always refer back to the prefixes. Prop is 3. So that means we have 3 carbons in our alkane, which is just a hydrocarbon, as we went over previously. So if we drew propane, right, this is a 3 carbon structure, and so you already know half of the formula, or almost half of the formula, right, which is C3, right, just by knowing the prefix. Now you need the H's, okay, and all you need to do to find that is just count it out and follow the octet rule, right? So we know that carbon, right, so let's write it down here. Carbon can have up to 4 bonds. That's all you need to know. And then and we know that in a line diagram, right, each of these points is a carbon. So let's draw right here. So each of those points is a carbon atom. Okay? Knowing that, and knowing the fact that each carbon has to have 4 bonds because of the octet rule, we just have to draw it in. So wherever you see a carbon, you just draw the rest of the bonds in to hydrogen, because that's in a line diagram. The hydrogen bonds are imaginary, like you don't actually draw it, but it's there. So if you actually drew it out, these 3, this carbon right here, right, let's point it out, this carbon right here, we bonded to 3 hydrogens. The reason for that is because in total, this carbon would then have 1, 2, 3, 4 bonds. Okay, and you can only have up to 4 bonds. Carbon can, because of the octet rule. Just like that, fill everything else in. So this carbon right here, right, already has 2 bonds. 1, 2. So the rest of the 2 bonds will be to hydrogen. And then last but not least, this carbon right here already has 1 bond, so it can have 3 more, and those 3 are to hydrogen. So you did not need to know CnH2n plus 2 in order to figure this out. You just had to know the prefix, right? Prop is 3, and then you had to know, and then you can just draw a 3 carbon chain, and then just fill in the hydrogens. So now that we have everything filled in, we already know C3, and H is the only other atom present here, because it's a hydrocarbon. That's what alkanes are. You just count it up. So 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So C3H8, right? And you can do that for any of them. So if you want to do a quick another example, if someone said, okay, give me the formula for butane, right? And so let's go to another page. You know butane, and you don't need to know. We're doing these examples so that if you don't know the formula CnH2n plus 2, you can still do it. So butane, you would write out butane. Then you immediately know that, okay, but means 4 carbons, right? So 4 carbons. And you know it's it's an alkane because the suffix ane. And you know that's just a hydrocarbon, that's it. There's only hydrogens and carbons in an alkane. So you just draw that out. So you know 4 carbons, 1, 2, 3, 4, sorry, I'll number it, 1, 2, 3, 4. And then the rest of the bonds have to be hydrogen. You know carbon can have only up to 4 bonds. So if we look at this carbon right here, right, because it's important to point out in a line diagram, the dots I'm drawing now are the carbons, right? And then the imaginary hydrogens are also there, but it's not shown. And so you know it has 4 carbons because it's butane, so you can already write that part of the formula down. And then you just draw the rest of the hydrogens in until that carbon has 4 bonds. So if we erase these, right, and start writing it in, so this carbon will have 3 bonds, each one to hydrogen, and why 3? Because it already has 1 bond to this carbon right here, so it can only have 3 more bonds, up to 4, right? So we just draw that in for the other carbons. So this carbon will only have 2 bonds to hydrogens because it already has 1 and 2 bonds already to carbon, so it can only have 2 other hydrogen bonds. This carbon will also have 2 hydrogen bonds, and then this carbon would have 3 hydrogen bonds because it already has 1 bond to this carbon, so it can only have 3 other hydrogen bonds, add up to 4. And that's it. So you drew butane, so now you just count everything up to come up with the actual formula. So how many hydrogen do we have? 1, 2, 3, oops, that's not, okay. 3, 4, 5, 6, 7, 8, 9, 10. So what's the formula for butane? C4H10. And you didn't need the formula CnH2n plus 2 to come up with this, right? But you can even check it if you wanted to. CnH2n plus 2, because butane is 4 carbons, N is equal to 4, and if you solve that out, you'll see you get C4H10. All right, and so that's basically like the basic intro for alkanes, and then the next video, we'll start talking about we'll basically be talking about more about alkanes, except this time we'll be talking about branches and parent chains in a deeper fashion. All right, so thanks for watching this video, and see you in the next video.